Okay, here we go with a nice question about displacement in a wave. As ever, please have a look at the question, press pause, try it, and then press play for the answer. Okay, so I'd put this down as one that I've seen before, and it's one that once you get used to it, you kind of will really get to grips with how to do these questions. First thing to pay attention to is the fact that we've got the wave traveling to the right. Okay, so we're expecting this profile, whatever it is, doesn't say it's a transverse wave. It could be a water wave, for example, to move to the right. Now, we're also told some information which is really crucial to getting rid of some wrong answers here. Firstly here, look what we've got. At time t equal to 0, point P has a displacement d equals 0. That's important because what we're going to be asked to do is plot graphs of displacement on the y-axis versus time as opposed to x. Okay, so here we've got a spatial graph and here we've got a temporal graph, a graph to do with time. We're interested in what this point P does over time. Now clearly at t equals 0, d must equal 0, so we can get rid of some options here. Any options here, C and D, can be got rid of purely because they don't begin at 0. Well, we're told that this point begins at equilibrium, and so therefore it must start there. And the question is, what direction is it moving now? This is where you need to go back to it. Direction of travel of the wave is to the right. I want you to pay attention to something to the left. Let's take this crest here. That means that this crest is moving to the right. And in order for that crest to move to the right, P must move upwards. Okay? Because remember, in any kind of wave, transverse or longitudinal, the particles themselves don't change position, the energy flows. And so all these particles are doing are sort of dancing around the equilibrium point. In order for the wave to be positive, then P must move up. Okay? Now we look at our graphs. Here in D, P is being pulled down initially. Well, that's not true because the wave is moving to the right, and which is why the answer here is A.